All right, chapter 19, problem 66. In part A, we have a 9-volt battery, a 2 microfarad capacitor, and a 7.4 microfarad capacitor. And in part A, the capacitors are in series. So, what's total capacitance? Let's start there. We want to know the energy and the charge, right? The charge and the energy. But first, we have to know the total capacitance. So, because they're in series, right? 1 over the total is 1 over 2 microfarads plus 1 over 7.4 microfarads, right? Because they add inversely. And I'm going to skip down and just put C total equals. All right, so they add inversely, so 1 over 2 plus 1 over 7.4. And now that we have that result, we need to make sure we invert it again so that we get to C total. C total is 1.57 microfarads, which meets with our expectation in that we expect it to be less than the smallest capacitor because they're adding inversely. So 1.57 microfarads, right? Okay, now charge is CV, the capacitance times the voltage. So we've got 1.57 microfarads times 9 volts, right? So that's going to be equals that times 9 is 14.2 microcoulombs, right? And it's microcoulombs because it's microcoulombs here because we have microfarads there. And a farad times a volt is a coulomb. The micro hangs out, it sticks with us, 14.7 microcoulombs. The next question, right? The next question is, what is the energy? Okay, so the energy stored in a capacitor is CV squared over 2. All right, CV squared over 2. So we have 14.7 microcoulombs times the voltage 9.0 volts squared. All of that with 1/2 out front, right? 1/2 CV squared. And what's going to get us? Okay, equals 14.7. Not 14.7, 14.2. Pardon me. 14.2. Okay, so equals 0.5 times 14.2 times 9 squared. And we get 575 microjoules. Micro hangs out again. CV squared is a joule, so 575 microjoules. And that's how much energy we have in part A. Okay, so part B. Part B do the same if they're connected in parallel. Well, if they're connected in parallel, the chief difference is that C total, right, is 2 microfarads plus 7.4 microfarads, and 9.4 microfarads. All right, and that's the chief difference. We're looking at 9.4 microfarads, and all right, Q equals CV is now 9.4 microfarads times 9 volts. So equals 9 times 9.4, 84.6 microcoulombs, right? And the electric field, E equals CV squared over 2, is 1/2 of the 9.4 microfarads times 9 volts squared, right? So 1/2 times 9.4 times 9 squared 380 microjoules. Back up a second. I see what I did wrong. Back here, I put in the wrong number. 1.57, not the charge, microfarads. 1.57 microfarads. So I did it wrong back there. So when we put in 1.57 microfarads, 63.6 microjoules. 63.6 microjoules is the energy. And down here we have for the energy 381 microjoules. Now, why did I know something was wrong? I immediately knew something was wrong because the answer I'd gotten here was smaller than one I got up there, but this was a larger capacitance, so there should have been more energy stored down here. So I looked back up to see, well, what did I do wrong? And what I did wrong was, instead of having CV squared, I'd stuck in the charge, right, and had QV squared. Well, that's not the energy we're after, it's CV squared. So E equals CV squared over 2, R equals QV over 2, R equals Q squared over 2C. All right, and that's it for problem 66. Okie doke.